The region near a magnet, electric current, where a magnetic force is experienced is called a magnetic field. The magnetic field is represented with the help of lines called magnetic field lines. These field lines possess certain properties. They are continuous closed curves. The magnetic field lines do not intersect each other. The magnetic field lines originate at the North Pole and terminate at the South Pole. Field lines are concentrated towards the poles. Magnetism is strongest at its poles. Inside the magnet, the field lines travel from south to north. The closer the field lines to each other, the stronger the magnetic field and vice versa. Take a permanent magnet and place it on a flat surface. Start sprinkling iron fillings onto the magnet. You will notice that the iron fillings align themselves along the field lines, forming straight lines running along the poles. The Earth acts like a huge magnet. This property helps sailors to navigate with the help of a compass. Earth's geographic North Pole is magnetic South Pole and vice versa. The magnetic field is strongest near the geographic poles and weakest near the equator. Magnetic field lines are formed even in current-carrying conductors. A simple experiment proves it. Take a square cardboard sheet and make a hole in its center. Through this hole, pass a conducting wire. Sprinkle iron fillings on the cardboard around this wire. When electricity passes through this wire, these fillings form magnetic field lines as observed previously. This proves that electricity also produces magnetism and it has field lines. The right-hand thumb rule states that direction of magnetism can be found while adopting thumbs up posture with the right hand. The thumb is placed facing the direction of current flow. The other fingers point at the direction of magnetic field. Vice versa also holds true. It is represented with the help of a corkscrew. In a circular current-carrying conductor, the magnetic field and field lines are produced in the same manner as in that of a straight current-carrying conductor. We know that the field lines are made of concentric circles. When they are far from the conductor, they form bigger circles, allowing only arcs of the bigger circle to be seen. These arcs appear as a straight line. This is the reason straight lines are observed at the center of the loop. A solenoid is a coil with many circular turns of insulated copper wire wrapped closely in the shape of cylinder. This intensifies the magnetic field. Enclosed in the cylinder is a soft iron core. A current-carrying solenoid is similar to a magnetic field produced by a magnet. One end of solenoid behaves as the North Pole and another end as the South Pole. Magnetic field lines are parallel inside the solenoid. The strength of a solenoid is directly dependent on the number of turns made by the wire. A bar electromagnet is similar to the construction of a solenoid. Take a material that will get magnetized such as steel or iron. Wrap a piece of wire around the steel or iron and connect its end to a power source such as a battery. Drop few paper clips near the magnetic material. You will notice that the clips get attracted to the metal. This is because the metal acts as a bar magnet. An electric bell works on the principle of electromagnetism. When current flows through the coils, the rods get magnetized and attracts the piece of iron attached to a hammer. The hammer hits the bell and makes it ring. Once the hammer hits, the contact is lost, breaking the circuit. The spring brings the hammer to its original position.